is the experiment of DC position control system. In this we have to control the position of the DC motor. This is motor contains in this unit with the help of this controller. So in this experiment we have 5 parts. First is to draw the graph between theta r, that is this potentiometer, command potentiometer, with respect to this VR. So what we have to do is we have to vary this dial for different values of theta r, and we have to note down the values for VR here, and then we have to plot the graph. Then second part is to draw the graph between this theta r and this theta naught, motor's rotary dial. Again we have to change this different values of theta r, correspondingly different values of theta naught will be obtained. We have to set the forward gain this dial. First we have to do it for k is equal to 5, then change the value of theta r, correspondingly noting the value of theta naught here. After that change the value of k to 8, then from 0 to 360 change theta r and correspondingly note the value of theta naught. Then next third part is to determine the position control using step command. In this what we have to do is we have to first set the command potentiometer dial to 90 degrees. Note down the voltage VR on this digital display. Correspondingly note the output V0. Then press this step command. Note down the value. This is Vs. Note down the value V0 here. Then we have to determine the steady state error. Steady state error is ESS is equal to V0 step V0 step this is of minus plus VR plus VR plus Vs. So steady state error you can write as VR plus Vs minus V naught S. So this is your steady state error. This is to be followed by using different values of k. Means first we have to put down the value of k is equal to 5, then say 7, then 9, and for the 3 cases we have to evaluate this steady state error. Now next part, fourth part, is to determine the dynamic response on the CRO. So for that we have to use the channel X and Y of CRO. X channel is to be put at 0.5, Y channel is to be set at 0.2 here. X is 0.5, Y is 0.2. These are connected on this CRO panel given on this controller. Set the command potentiometer to 90 degrees. Then what we have to do is we have to set the K value, forward gain value, to any point. Say I am setting it as 10. Tacho feedback is 0. So we have to do capture, and then we have to press step. Then after a delay of 11 seconds, I got a response on the CRO screen. That is, this will be the response. This is the response of my system without having tacho feedback. So on this response, I have to calculate 2 parameters. That first is your maximum overshoot, that is this value. Maximum overshoot is this to this. We have to note down here the maximum overshoot, and then the TP, the time taken by the first peak to appear on the CRO. We have to note down TP. Then why we are doing this, we have to calculate the transfer function for second order system. That is, the standard equation is omega n square upon s square plus 2 zeta omega ns plus omega n square. So by MP is maximum overshoot is e raised to power minus pi zeta upon 1 minus zeta square. So we have the value of MP. By putting the value of MP here, zeta is evaluated. I have the value of TP. TP is pi upon 1 minus omega n under root 1 minus zeta square. So zeta is evaluated from MP. So TP is again calculated from CRO. Then omega n is calculated by this formula. Then putting the omega n and zeta values in this standard equation, the transfer function of this second is to be calculated. Then last part is to use this tacho feedback. Now on the same forward gain, set the tacho feedback to 0.4. Then again press capture, then step and determine the response on the CRO. Then again it is a delay of 10 to 11 seconds. We have the response of this kind. Now if we compare it with the previous response without feedback, I got that there are the oscillations are reduced. So this is why we are doing the feedback, that my the oscillations are reduced and my steady state is achieved earlier than without feedback. We can also verify this that by having the lesser gain, that put the forward gain to 5 and again tacho feedback to 0, press capture, then step, again evaluating the response on CRO. Again I will see now that my oscillations are still reduced. Means you can say that by having the low gain, the steady state is achieved earlier, but if the gain is high, oscillations are high. So oscillations for that high gain is reduced by adding the feedback from here. So we can have this position control by using this controller.